Over 1,000 tokens per second on a single GPU.
Wait, say that again.
1,008 tokens per second. That's what the VLLM team measured independently when they benchmarked DiffusionGemma on a single H100 GPU.
Okay, I need a reference point, because that number means nothing to me right now.
So a normal autoregressive model, think standard Gemma 426B, generates around 70 tokens per second on that same hardware.
70 versus 1,000. That's not an improvement. That's a different category of thing.
That's what we're talking about today. Google DeepMind dropped DiffusionGemma on June 10th, 2026. And it's not just faster. It works completely differently from every language model you've heard us talk about before.
And look, we spend a lot of time on this show watching AI get incrementally better. Slightly smarter, slightly cheaper, slightly faster. This doesn't feel incremental.
It genuinely isn't. So let's get into how it actually works, because the mechanism is the whole story here.
Right. Because I've been staring at this, and I keep coming back to one question. How?
Okay, so here's the thing. Every language model you've ever used, ChatGPT, Gemma, Claude, all of them, they generate text one token at a time, left to right. Each word depends on the previous word.
Like the model is writing a sentence the same way you type it.
Exactly. DiffusionGemma doesn't do that. It generates an entire block of 256 tokens in parallel, all at once.
Hold on. All at once? But how does it know what to write in the middle of the sentence before it's figured out the beginning?
So this is where the diffusion part comes in. You know how image diffusion models work? They start with noise and gradually denoise it into a picture.
Yeah, like stable diffusion, that kind of thing.
Same idea, but for text. DiffusionGemma starts with a block of masked or noisy tokens and runs multiple denoising steps. Each step, the whole block gets clearer. The sentence emerges from noise.
That's genuinely wild. So it's not writing left to right. It's more like developing a photograph.
That's actually a really good way to put it. And here's why that matters mechanically. Traditional models use what's called causal attention. Each token can only look backwards. DiffusionGemma uses bidirectional attention. Every position in that 256 token block can see every other position simultaneously.
So, the last word in the paragraph can influence the first word as the whole thing gets refined.
The sentence knows where it's going before it gets there.
Okay, that's actually kind of beautiful and also slightly unsettling.
It's a little unsettling, yeah.
So, if you heard our episode about your iPhone running 70B models, this is basically the sequel. Because we were already asking how much more performance we could squeeze out of consumer hardware. And now Google's answering from a completely different angle.
Different architecture entirely. And speaking of the architecture, let's talk about the actual model. Because this thing is labeled 26 billion parameters total. 25.2 billion total parameters.
That's huge.
But here's the twist. Only about 3.8 billion of those parameters are active per denoising step.
So it's not running all 25 billion every time it generates something.
It's a mixture of experts' design built on the Gemma 4 architecture. Different experts activate for different inputs. You get the scale when you need it. You don't pay for it when you don't.
That's clever. That's really clever.
And it's open weights under Apache 2.0. So anyone can download it, fine-tune it, deploy it commercially.
Wait, Apache 2.0? Like fully open? Not that weird open where there's 17 pages of restrictions?
Fully permissive. According to the eesel AI breakdown, you can use it commercially without restriction.
Okay, so Google just handed the research community 1,000 tokens per second diffusion model for free. That's a statement.
It's definitely a statement. Now here's where I want to pump the brakes slightly, because I think the speed number is real, but it needs context.
I knew you were going to do this.
I'm doing it. So the Awesome Agents review flagged benchmark score gaps, We're talking 5 to 19 points behind Gemma 4 26B on reasoning, math, and vision tasks.
Okay, that's not small.
It's not. On some of those tasks, 19 points is a meaningful gap. So you're trading some quality for a lot of speed.
But hang on. For a lot of real-world use cases, do you need to win a math Olympiad? Or do you need to process 10,000 customer support tickets in an hour?
And that's exactly my concession point. For throughput-heavy applications, okay, yeah, I'll give you that. The trade-off is probably worth it.
It's not even a trade-off for those use cases. It's just better. Full stop.
The use cases where speed is the bottleneck, DiffusionGemma just removes the bottleneck entirely.
And there are so many of those. Real-time translation, live captioning, agentic pipelines where one model is calling another model, calling another model.
The latency compounds in those pipelines. If each step is up to 4 times faster,
The whole chain becomes a different product.
there's also the hardware question. At full BF16 precision, you're looking at around 52 gigabytes of VRAM. That's high-end server territory.
Okay, that's a lot.
But quantized down to INT8, you're at about 28 gigs. And at the lowest quantization, it can run from around 18 gigabytes.
So it'll fit on a beefy consumer GPU or a mid-range workstation. That's not nothing.
It's not consumer laptop territory, but it's not exclusively data center territory either. The community's already running it.
And it takes multimodal input, right? Like you can feed it images and video?
Text, image, video as inputs, but the output is text only. So don't expect it to generate images. It reads the world visually. It responds in words.
Which honestly, for most applications, is exactly what you want.
The bigger picture question for me is what happens to the whole field now? Because diffusion for text has been a research idea for years. Nobody shipped it at this scale with this performance.
Google just made it real. Like, productionizable real.
And they open sourced it. So every lab, every startup, every university researcher wakes up tomorrow with access to the weights and can start building on top of this architecture.
The next 6 months of papers are going to be wild.
I want to watch whether the benchmark gap closes, because right now the story is speed at a quality cost. If someone fine-tunes this on domain-specific data and closes that gap even partially,
Then, the trade-off almost disappears.
also watching whether VLLM and other inference frameworks build native optimizations for diffusion models. Right now, the 1008 tokens per second number is already remarkable. Optimized inference frameworks could push it further.
And I want to see what agentic frameworks do with this, because multi-step AI agents are one of the biggest bottlenecks in real deployments right now. If you can make each reasoning step significantly faster.
The economics of running agents change completely.
Completely. We're not just talking about chat. We're talking about autonomous systems that actually run fast enough to be useful in real time.
Here's where we land. DiffusionGemma is a real architectural shift. Not vaporware, not a benchmark cherry pick. Google DeepMind shipped it June 10th. Open weights, Apache 2.0, and the independent numbers hold up.
The quality gap is real, and you shouldn't pretend it isn't. But the speed is also real. And for the right applications, this changes what's possible right now.
The text generation paradigm that's been locked in place since the original GPT models just cracked open.
I'm going to be thinking about this one for a while.
If this got your brain moving, hit subscribe. We're in your feed every day with stories that actually matter.
And if you've got thoughts on DiffusionGemma, or where you think diffusion language models go next, find us.
I'm Alex.
I'm Sarah. Go build something fast.